In this exercise, I want you to solve this game. So it's a 2x2 zero-sum game, and we've shown the utilities to the player Max. And so tell me what Max's strategy is by putting in probabilities in these two boxes for his two plays, 1 and 2. And tell me what Min's strategy is by putting in probabilities in these boxes. And then tell me the value of the game, the expected utility to Max. The answer is both players have a rational mixed strategy. For Max, he plays 1 8/17 of the time and 2 9/17 of the time. Min would play 1 10/17 and 2 7/17, and then the utility of the game to Max turns out to be 5/17. In this scheduling problem, we have a network of actions with the precedence relations between them and the duration of each action shown in each box. And what I want you to do is for each action, fill in the earliest start time in the upper left and the latest start time in the upper right. Here we see the start times for each of the actions. Note that the critical path, in which the earliest and latest start time is the same, goes straight down the center. Here's a game tree for a stochastic two-player game. There are max nodes, min nodes, and chance nodes. And what I want you to do is back up all the values, so fill in a value for the value of each of these nodes, and then check off all the nodes that could be pruned away by a procedure that's similar to alpha beta, but updated to handle chance nodes. So what I mean by that is a node can be pruned away if evaluating the nodes is not necessary to figure out what the best moves are for max and min. For the chance nodes, all the possibilities are equiprobable. So here there's a 1/3 chance of each of these, here there's a 1/2 chance of each of these. And in this game, the result of every game is either a +1, -1, or 0. And all the players know that those are the only possible outcomes for the game. Therefore, the players can take that into account when trying to figure out which nodes to prune away. Here are the backed up values. For the min nodes, the backed up value is always the minimum. For the chance nodes, it's the expectation or the average. And for the max node, it's the maximum. And here are the nodes that can be pruned. This and this can be pruned because in each of these cases, min has achieved the best possible play that min can get, and therefore doesn't need to consider any other possibilities. Once you know you can win the game or do the best you can, you don't need to find another way to do just as well. This node here can be pruned, and thus all the ones below it, because at this point, when we're trying to evaluate this node, Max knows he can get at least 1/3, and here, once we know that this node is worth -1, then we know that regardless of the value here, that has to be somewhere between -1 and +1. So therefore the expectation has to be between -1 and 0. And if 0 is the best that this can be, Max knows he already has 1/3 over here. Here's a two-player game. Each player has 3 possible moves. Now what I want you to tell me is first, does A have a dominant strategy, yes or no? Second, does B have a dominant strategy, yes or no? And third, click on all the boxes that are equilibrium points. A does not have a dominant strategy, but B does. If B plays the middle E, then in this case, B will get 5, which is more than 3 or 2. In this case, B will get 7, which is more than 2 or 4. And in this case, B will get 8, which is more than 7 or 5. So that makes this play the dominant strategy for B. Now, if B is going to do that, then what should A do? Well, A should try to get the best possible value that A can, and that would be here, and that makes this square the lone equilibrium point.